Good morning, all. Today, I'm taking you a topic on alternators. I'm not sure how many of you know what an alternator is, but I'm damn sure that you are all taking advantage of alternators in your day to day life. So, let's focus on the applications of alternator first and make us aware how important is an alternator in our day to day life. And after that, let's move on to the construction and its working details. An alternator is a magical device which converts mechanical energy from turbines to the electricity that powered our home. So, in a car, it's a lifeline that is powering from headlight to the radio while charging the battery. Imagine a night drive without headlight. How scary it is, right? Thanks to alternator. In power plants, alternators play a massive role, whether it is a thermal power plant, a nuclear power plant, or a hydroelectric power plant. It is this incredible versatility that makes alternator indispensable in our day-to-day life. The alternator works on the principle of Faraday's laws of electromagnetic induction that we are studying from our school days. An EMF is induced in a conductor when it experiences a change in magnetic flux. And in case of an alternator, the magnetic flux is created by the rotor within a stationary set of conductors. And coming to the construction of alternators, the main three parts are the stator, the rotor, and the excitation systems. The stator is the stationary part of the alternator, which is having a core, and this is made up of laminated steel sheets, and this is having slots in which three phase windings or this armature windings are placed. And next is the rotor. The rotor is the rotating part of the alternator. It is of two types, that is salient pole and cylindrical pole. And the application of salient pole is in hydroelectric power stations, and cylindrical pole is in thermal power plants and nuclear power plants. The rotor is actually a magnet. It can either be a permanent magnet or an electromagnet. And if it is a electromagnet, it has to be powered from a DC supply. And this is the excitation system. So, the excitation systems will supply the DC current to the rotor winding to generate a magnetic field. And in modern alternators, we are using automatic voltage regulators. So now let's see the working of an alternator. The rotor is, that is the electromagnet, is excited and it produces a magnetic field. And you can see a stator conductors which is connected to a load. And when this rotor magnetic field cuts the stationary conductors, an EMF is induced. And as the circuit is closed, a current is passing through it. And here, this is the figure of an alternator, stator. That is, you can see the three phase windings here, and this is the rotor. And when we are giving the excitation, a magnetic field is created, and this magnetic field is a uniform magnetic field, a constant magnetic field. And you can see this rotor is driven by a prime mover. That is, it can either be a steam turbine, a diesel engine, etc. And when this prime mover rotates this rotor, this magnetic field that is created will be rotating, and then this rotating magnetic field will cut the stationary conductors or the stationary three phase windings, and as a result, an alternating EMF is generated and a three phase power is generated. And this is the working. So, next time when you flip a bulb or put switch key on your car, just give a nod to alternator as it is working tirelessly behind the scenes, making sure that you are getting enough power. Thank you.